Good afternoon and howdy. Pleased to have you all here for the third of our Centennial seminar series. We want to thank, as before, Cotton Foundation for their support of this series, and so appropriate, especially for today, since the topic for today is all about the cotton engineering that's been done by this department over the previous century. We're honored to have today Dr. Calvin Parnell, one that most everybody in the room knows. Calvin, of course, is a Regents Professor and the inaugural holder of the chair in cotton engineering, ginning, and mechanization. In addition, he also serves as the director for our Center for Agricultural Air Quality Engineering and Sciences. Dr. Parnell will share a little bit about his own personal background, but I'll also just let you know that he is an ag engineer by training. His first degree from New Mexico State back in '64. Got a Master of Science from Clemson in agricultural engineering, followed by a PhD in environmental systems engineering, also from Clemson in 1970. As I mentioned, many of you know Dr. Parnell. We're out in the foyer, Calvin, just for your information. I was hearing some of the warnings you've already received about keeping people awake and making this an entertaining presentation. And I wanted to note, many of you have attended some of the others, and so you've seen this already, but we do now have the turntable used in the early classes for display of equipment, rotation and elevation and all of that. Doesn't have that capability today, but it does make a pretty nice little dance floor, and so he can do his song and dance up here to entertain us all. I'd also like to recognize Peggy Parnell. Thank you for being with us today. And Calvin, I'll turn it over to you.
These kind of newfangled devices are kind of hard for me to cover. I'm from the old school. Charlie might remember the old school. I want to recognize, I'm honored to be talking about this today, and I want to recognize a few other people in the audience. Sally, Romy Sorensen, Paul, Julia, Lambert Wilkes' daughter. Fantastic. One other person I want to emphasize is, and he says, put it up here. If it wasn't for my right-hand man up here, who's a Marine Corps guy, I'd be in trouble. How about that, Russell? And his family. That's fantastic. I appreciate you all coming. Bob Avance had some little health problems back there, but he's doing better. We've had a few other people in the audience. Terry, I hadn't seen him very often, but he's up there. He got his finger in his ear, but he's thinking about not going to sleep. This is a topic I love. I'm going to talk a little bit about myself here, and not very much, because we have a situation here in this department that we have made a major, major contribution to an industry, and that's the cotton industry. How did that happen? Well, one of the major leaders in this thing is Lambert Wilkes. And if you'll read that, there's a little thing out there in the foyer about Professor Wilkes. Now, the reason why I'm telling you a little bit about myself, because it kind of led up to where we started using the module builder. I was a calf roper in New Mexico. Not very good. Went to New Mexico State. Got my degrees, as Steve said. And thank you, Steve, for letting me do this. Then went to Clemson. In the meantime, I married this lovely lady that was a cheerleader when my brother was playing sports, and Doug her to Clemson. We got my PhD, went in the Army, came out and said, oh, yeah, you got to go to the engineering laboratory in Lubbock. Okay, so I worked there 4 years. Had an opportunity to come to work for Texas A&M, Texas Agricultural Extension Service, cotton ginning specialist. Love that. I'm at Lubbock, and I'm getting that job, and it's the best move I ever made. Although my lovely wife, she didn't want to leave Lubbock. She had a bunch of friends and had a dress shop there that she loved. And then we came to going down Texas, and she said everything was bad. So she saw the head shed out there from Texas Avenue. She said, this is good. By the way, I have some students out there showing signs up. Hurry up, Dr. Parnell. Where are you at, Victoria? I said, okay, check it. All right. Anyway, the first thing I did as extension specialist, I went into work, and I had Bill Stewart and a number of other extension specialists that are not there anymore. They said, you got to go to the Beltwide in Lubbock, in Dallas. So I went to the Beltwide in Dallas and listened to Lambert Wilkes talk about the module builder. I had come from Lubbock, and in Lubbock they had a guy from an industrial engineer who was talking about ricking, and I'm going to show you some differences in the two here in a few minutes when I get to the slides. Anyway, in those days, extension specialists got together, and they went down the valley, and they went up to Corpus, and they had a bunch of people in each of these places listening to get training on cotton ginning or on plants and et cetera, and entomologists. And I went to the valley and came up to Corpus and gave my presentation, which was Lambert Wilkes' slides. I got his slides. And I'm giving this presentation, and this guy comes. It's fantastic how you get sharpshoot every now and then. It turns out to be good. He said, Dr. Parnell, you said that you could module cotton in Corpus Christi area and store it for a certain period of time. I said, yes, sir. He says, you're wrong. You put that stuff in a module, it's just going to rot. The humidity around here is so high, there's no way you can store seed cotton like that. And by the way, somebody else was involved in determining what the moisture content would have to be to prevent damage to the crop. Okay. Anyway, I'm riding with Fred Elliott, and he says, no, Dr. Parnell's not wrong. So I'm listening to that, and I get a call from the county agent in San Patricio County in Centennial. He said, we have to put a module demonstration on. Okay. And I went back to my office, and being a young, green, wet behind the ear extension specialist, I said, what the heck is a result demonstration? Okay, Dr. Parnell, here's how you do that. So we talked to Lambert. He loaned us this Model T module builder. I'm going to show a picture of it here. And then we got some people from Extension Service to help pull that Model T module builder from College Station all the way to Centennial, Texas, so we put on a demonstration. I might add that the county agent called me, and he was a little concerned because some of the people, the farmers in the room, didn't think they want to put 10 bales of cotton in a module because somebody said, Dr. So-and-so said it's going to degrade. But he got three volunteers. I go down there with a module builder, a Model T module builder, and it's a wide load. We get to this town which where, name of that town, Peggy, can you tell me? She says LaGrange, thank you. LaGrange. In LaGrange, Texas, you go into a town, and we have this wide load, and I'm in a pickup. And we're concerned that we're going to get up through that old bridge. The old bridge is wide enough for us to get through. He says, Calvin, you go up there with your pickup, and you stop. Anybody come down the hill. Okay, so I'm going to pick up, and I got a little flag there. And I parked the pickup, and I'm over. And this guy is coming down that hill. He's like Charlie is right now. He's got his eyes shut, and I think he's whatever. Anyway, he gives me the one finger salute, and it's not this finger. And so I'm a little bit in trouble there. And I look down there and says, oh, my goodness, we're going to have a wreck. Anyway, to make a long story short, the guy who ran the pulling the module builder, he moved up far enough over, and he was hitting the structure part of that old bridge. We put a dent in the structure part of it. We had to do a little repair work when we got down to Centennial, Texas. Anyway, we get down there, and we only took 3 pallets with us. And we have a tilt bed trailer. I'll show you a picture of that in a minute. The tilt bed trailer is designed so you can take the pallet and winch it up onto the trailer, level it out, take it over to the gin, and drop it on the ground at the gin. Drag it around where you want to. We got everything down there. Did a little repair work on a module builder, and we did the modulating of 3 modules. All of a sudden, there was a threat of a hurricane. And there's 3 or 4 farmers came over and says, hey, come over to my farm and put a module up there. I said, no, we can't do that. Have to put it on a pallet. We only have 3 pallets. Oh, I'm sorry. So anyway, next step is to get the module from the field, that you got it made, over to the gin yard. And the way we do that is we tilt this tilt bed trailer down and we winch that pallet onto that tilt bed trailer and then straighten it out and go over to the gin yard and put it on the ground. So Lambert didn't give me a whole lot of instructions, but I said, I'm an engineer, I can figure it out. And so I get over there and it's a 24-foot by 8-foot by 8-foot module, 10 bales. And I winch it on that tilt bed trailer, and it's 36 feet long. And I top it all the way to the top. Now, you know, you'd think an engineer, even one that had very little experience like me, would know that you shouldn't be doing all the way to the top. And so I did. And I'll go there, and I got the farmer and the county agent in front of me, thank goodness. And so I start lowering that tilt bed. So my thinking was, it's rollers on it, so it's going to start rolling down, get to the ground, and I can pull off of it. That's my thought process. And I tilted down. I got 45 degrees. It hadn't moved. Producer's right there, and the county agent's right there. And I wiggled a little bit, and that module was 20 miles an hour when it hit the ground. It went right under that shed, this bit slicker than a whistle. And that producer says, went under there slick, didn't it? Yeah, I didn't know what I was doing, and I got lucky. Every now and then, engineers get lucky. Now, what I want to do now is play the video that I have of Lambert talking about the module.
Seed cotton module building is a new way of handling harvested cotton for transport from the cotton field to the gin. In the background here, you'll begin to see a machine that was developed by Lambert Wilkes, Associate Professor at Texas A&M University in the Department of Agricultural Engineering. This is what they call the seed cotton module builder. And Lambert, tell us just a little bit how this machine operates.
The machine is parked on a turn row over pallets in the field of cotton, and the cotton is dumped directly from the harvester into the machine. Now, the machine is set up with a traversing compaction unit, which is the yellow portion of the machine on top. And as the cotton is deposited into the machine, this compaction mechanism levels the cotton out and compresses the cotton down into the chamber of the machine.
Lambert, what are some of the problems that stimulated development of this seed cotton module builder?
There's several problems that are involved in the process of getting the cotton from the field to the gin, and also in the ginning and harvesting phases. At the present time, the harvesting capacity is much greater than the ginning capacity, and the conventional trailer system is being used to accumulate this cotton at the gin. The trailer is being used primarily in some cases as a storage unit rather than a transport unit. And in many cases, the trailers are tied up at the gin maybe 4 or 5 days. And this will cause several problems. Either the harvesting operation is ceased, or else they have to get more trailers, or they might have to increase the ginning capacity. This system, we hope, will tend to alleviate some of these problems. And what we're attempting to do, and we're working with this in cooperation with Cotton Incorporated and a cooperative project, is to develop an economical system of handling and storage. The gin has a capacity of operating 12 months out of the year. However, the harvesting should be accomplished as soon as the crop is mature and ready to harvest. So what we're doing, in effect, is to develop an accumulating system to accumulate the cotton as fast as it is harvested, and then haul it to the gin in a manner which they can gin it more efficiently.
How long can it actually be stored in the module state?
The moisture content is the determining factor. As long as the moisture content is below 12%, our studies have shown that it can almost be stored indefinitely. However, if the moisture content is above 12%, you will stand a chance of losing quality in the seed as well as the lint. You probably get some staining of the lint.
One question, finally, that's in my mind, and I'm sure it's in the mind of several others that are looking on today. How do you get this module, then, from the field to the gin? How is it transported?
We have a trailer that we built for transporting this. The trailer is made similar to a lot of the utility-type trailers. It has a tilting bed and a winch mounted on the front of it. And we back the trailer up to the module, stack of cotton, which is constructed on a plywood pallet. And we attach the winch to the pallet and winch the pallet onto the truck. And it's transported to the gin without any sideboards. The only thing you have on it is a tarp over the top to keep the loose cotton from blowing off.
And you just brought to mind one more advantage. It goes there a little faster than in the conventional cotton trailer, doesn't it?
It not only goes there faster, in fact, we can travel at speeds around 40 to 50 miles per hour. And we also have a higher density. The density in these modules is about twice that of what you'd find in a regular trailer. So that means you can haul twice as much cotton and make half as many trips to the gin.
Thank you, Lambert Wilkes, who is a researcher for the Texas Agricultural Experiment Station at Texas A&M University, for describing a machine that he developed to help the cotton industry, a seed cotton module builder. This is Larry Quinn reporting.
That was done in 1972. Need a flipper now. Here we go. What Professor Wilkes is talking about there is something that was a common problem, and the engineer there at Texas Tech thought he had solved that problem, but he didn't. Here's what it looked like back in the turn of the century, about the time when we were looking at our department, 1915 or whatever, and you had different things, different kind of carriers to get the cotton to the gin. The gins there would be something like 5 bales per hour. We have a gin today that can gin 100 bales an hour, even more than 100 bales an hour, so it's a big difference. This is what Lambert was talking about when he says you get covered up with trailers, you're actually storing seed cotton in trailers. That was not very efficient and not very a good way to do business. The 1970 problem, fiber and seed quality losses, we had the ginning rate, harvesting rate much faster than the ginning rate, and that was what was causing the problem. And in the Texas Tech, Dr. Milton Smith, that's what I was talking about, the ricking system, you can store rick cotton at the terminal. What that meant is you can continue to get the harvester, which is the most expensive activity you had, continue to go out there and gin cotton. Harvest cotton. This is the way the ricker works here. It just basically came down and compacted the cotton. One of the difficulties here is the cotton was not at a very high density, mainly because the rick system was fairly light. Here it is. Here's an operation ricking in the high plains of Texas, and what you ended up with is a long row of seed cotton in the field, and sometimes in West Texas you get some high windstorms and you kind of lose a little cotton in the process. But to get the cotton to the gin, you're still using trailers, and trailers, in effect, are still being used as storage devices, which is not necessarily the right way to do it. So the module builder came about, and this is actually one of the papers Lambert had is from in the 60s, prior to I went to work here. I'm trying to remember now. It was prior to my coming to Texas A&M. This is a cotton gin. I just threw that in. Now here's a slide right here that I want you to look at. You can kind of tell by the hat where Lambert's at. He's always wore that hat. Now I'm going to find a pointer here. Here we go. That's J.K. Farmer Jones. J.K. Farmer Jones worked with Cotton Incorporated. He was one of Lambert's partners they worked with. He also worked with Professor Sorensen and getting the moisture content correctly. and also with Otto Kunze. Now this is the next step. We now can take cotton, put it in a module. We know we can store it for long lengths of time. But what happens when it gets to the gin? Oh, you get some people get up there and use a suction pipe and suck it off on the gin. No, Professor Wilkes says, no, there's a better way to do that. He says, let's take and make a module feeder. So we have modules back here moving in the module feeder, and he designed it, and so therefore we mechanized the module feeder. This is the pictures of what happens in a module builder schematically. Here's the Model T module builder that we had down in Corpus Christi after we'd repaired it for that slight problem that we had on that bridge there. This is a good picture showing the pallets down here, the wooden pallets. We had wooden pallets and metal pallets. Now that's where we were about in that early 70 period. Here's another trailer. It's not the same trailer, but it doesn't have the rollers on this one. There's the pallets that he used in this process. One of the difficulties that we had there in that module building system was we had to accumulate the pallets, especially the metal pallets that get bent and this kind of thing, and so you had to repair them and replace them. All of a sudden we came with something new. This came from the Midwest, and that is a module transport truck. Taking the module and moving it on a truck rather than winching a pallet up and taking it over to the gin yard. Now, this module transport truck was used in other applications in agriculture, but we used it for modules. Here's how it worked. This chain right here is moving under this bed of cotton. It's kind of eating its way underneath it. And the speed at which this module truck is moving this direction is synchronized with with the change speed of when the module goes up on the module truck. Here's another picture of it actually being loaded or unloaded. It could be either one. Probably loaded in this one right here. Now I want to stop with this one just a second. When we did our first module demonstration in South Texas at Corpus Christi, we stored the module for 90 days. We had a representative from USDA Cotton Classing Office come in and take samples, and he says after 90 days, in which they had a hurricane during that time, the quality of the fiber was excellent. But then we didn't have the problem that we had people thinking it's going to degrade. Now this is in Glasgow County here. This particular demonstration was. And I might add that there was a fellow who worked in Lubbock, and he built module builders. His name was Raymond Adams. I asked you that time. I have been asking Russell up there. My good buddy from North Carolina says, yeah, Raymond Adams. And I keep forgetting his name. But anyway, I saw Raymond out there at the Gen Show this last week. I had a demonstration here scheduled. And I wanted somebody to pay the barbecue. There was actually 3 manufacturers of module builders at that point in time. One in California, one in Georgia, and one in Lubbock. Raymond Adams was associated with one in Lubbock. He said, Calvin, I'll pay for all of it or just a part of it, whatever helps you. And he paid for all of it. Because the other 2 says, we're not making enough money off module builders. We're not going to give you any money for a barbecue. Now, we talked about the system out there was harvesting cotton, and one thing we didn't have to talk about yet is the bull buggy. This is the Model T bull buggy right here. There's actually 2 of them out there on that demonstration, and we were doing that. Now this is basically, I think Dr. Kobler designed this thing, but I'm not sure. This is the winch they had to take the bull buggy, pull it in the air so you could dump the cotton that's in this bull buggy into that module builder. The logic there is you don't want to run the harvester back and forth in the field because it's not very efficient doing that. So Lambert designed a bull buggy. Little sidebar note here. The people who putting it in the bull buggy, farmers out there in Glasgow County, I gave them some instructions because I'd heard that there was a little problem with this right here. It failed the first time. They had to repair it a different thing. The person that's doing the lifting this thing up with that crane has one foot on the tractor and one foot ready to leave there, just in case somebody didn't design it just right. So anyway, and it didn't fail. But I went out to the field and I told this guy, I said, don't get too ambitious here, because all we're trying to do is demonstrate the concept. And I went back out in the field and he had 4 or 5 of his employees tromping that trailer. I said, instead of 2 bales, we're going to have 3 bales, maybe even 4 bales. Man, it had a lot of cotton in that particular trailer. And I was a little concerned about it. Notice I'm over here. It's before I gained any weight. I was a good-looking, young, thin man at that point in time. And so I'm watching that too, but I'm also about a little ways back from that thing. And I'm giving some talking at the same time at that demonstration. And it went well. Now, after that demonstration, they lined up in the gen office. There's 21 module builders, $22,000 to $24,000 each, were purchased by the farmers in Glasgow County. And Raymond Adams says, they told him, we're not going to pay for one module builder until all of them are delivered. He tried to collect on that, but he wasn't successful. He came down there, and after the 22nd module builder was delivered, they lined up in the gen office, wrote him a check, and they sold a module builder there in Glasgow County. Okay, this is modified the picture a little bit, but this is the dumping of that trailer there into the module, and it worked well. These are some pictures of some individuals who have come through this department and been successful. Let me start in the upper left-hand corner. That happens to be Brian Shaw. He's the chairman of the Texas Commission on Environmental Quality. Kelly Green came to talk to my class. Kelly Green came to talk to my class today, and he works with the Texas Cotton Gin Association. And here's John Manura. He's working with the Gin Laboratory in Lubbock. Here's Tony Williams. Without Tony Williams, I wouldn't be the endowed chair, because that's basically, they put the initial thing down. And this is Jimmy Ropolo. Over here I got Dr. Cersei hiding back in the corner, so I didn't have to show him up to too good-looking guy there. Another good-looking guy here in a department at that point in time is Sergio Caparetta. This is Ross Rutherford. His nickname was Lumpy. I won't tell you why his nickname was Lumpy. And I happened to be running a module builder on some stuff we're doing out there. And then Dr. Lepore, he had a water meeting to go to. And I know the reason why he went. He says, I've heard enough of Calvin Parnell. I don't want to go there and spend time. He'll put me to sleep. It'd be too boring. So anyway, he went to a water meeting. This is the set of slides that I had prepared for this. Now, I'm prepared to answer questions. Looking up there at Russell's son. You got a question for me? Yeah, man? Oh, man. Okay. Any questions about that of anybody? Talk to me. Tell you what, my hearing aids work about half the time. Slow down just a little bit and say it a little louder. I have John Deere has a round module. Yeah, they sure do. We know a little bit about that. What do you want to know about that? Sure. On the round module, by the way, let me add this discussion before I go forward. There's a number of people in here that have been working in cotton. Up at the top of the room there, you got Alex Thomason looking up there around here. We get a number of people working with cotton. Okay, what they do is they come back and they form the module on the picker. Now, generally speaking, most of the round modules you have are from pick cotton, although John Deere has now come back with a SIP model of that. And what they do is they wrap it, they condense it, they wrap it with plastic, and they take it over to the gin, and they can handle it at the gin. But there's only about, I'm estimating now, about 30% of the cotton harvested in the U.S. is with round bales. More of it's harvested typically of what we had here. Answer your question? Talk to me. Sure. Let's talk about the roller ginning. Lambert had a gin that in fact took the longer fibers off the seed and allowed the shorter fibers to go back and be ginned in a standard gin. And that was I forget what they call it. Do you remember what they call it? Cage gin. Yeah, cage gin. And that offered some opportunity, but the problem with that is you had to bale the long fiber and you had to bale the short fiber indifferent. I mean, you had to process it differently. But anyway, anybody who did work at Case Gym was probably working with Lambert Wilkes. Now, in terms of air quality, we have a group that does a lot of work in air quality. Victoria, where you at, Victoria? Okay, Victoria's up there, and Will's up there, and Walter. Walter's family originally came from South Africa. He's a really sharp young man, and let's see, I'm trying to think of anybody else. How about it? You got something to say up there? No. Mm-hmm. Okay. Yeah. Well, the issue really is, and I was on the Air Quality Task Force. There was an attempt made by USDA, by EPA, to impose penalties on agricultural facilities, cotton gins, grain elevators, feed mills, cattle feed yards. Reason why is they didn't know what the emission rate was. And so we developed and went to a lot of trouble to come up with an emission factor to determine what the emission rate was coming out of the thing. I don't want to give a whole lot of secrets up here. Ask me something else, somebody. We've made some progress. We have emission factors, cotton gins, grain elevators, feed mills, cattle feed yards, and dairies. I got a young man up there in top of the room who's a permit engineer. Talk to me, young man. Talk to me. What company are you with? AECOM. Okay, tell us about AECOM. Tell us about AECOM. I think I've got about 8 companies in the state of Texas that are hiring our graduates to go work as permit engineers, and AECOM is one of them, and we've been quite successful placing students in this area. Any other questions, anybody? Yeah, talk to me, Shay. Oh, wait a minute. Let me pass this word. Got to be careful here. Shay is a former graduate student of mine. When he was talking about AECOM, he's a former graduate student of Brian Shaw's. So, Shay, you're one of my former graduate students. Don't say anything negative about me now. I love that question. Now, did I pay you to ask that question? I got you. You know, we have so much opportunity today, but it's different than it was. I mean, when Lambert was getting funding from Cotton Incorporated, it was a different time. When Romy was doing work on his work on, and when Otto Kunze was doing work on his stuff, it was a different time. There's going to have to be a new paradigm of how you fund research than what we have now, because you're kind of scraping the bottom of the barrel here and getting research funding. One thing we have going for us is the quality of the students we have going to this university, majoring in bio and ag engineering is fantastic. Will, say something that says you understand English. Okay. Will is outstanding. We have a number of... Walter, say something good. Something good. Okay, I got bashful. Talk to me, Sergio. I probably ought to call on Russell down there. No, we have a reputation here of developing the 1D 3D cyclone. The history of the 1D 3D cyclone. Well, we did in the early 70s. We did a number of testing in the laboratory of cyclones, and we changed a number of things, and we basically ended up with a 1D 3D cyclone that somebody in California got excited about this work done at A&M in 1973, 72, and they says, we got this problem. The California Air Resources Board is saying we have to put some additional controls on to meet the requirements in the state of California. And they came back and they used the 1D 3D cyclone. They actually called, and I gave the individual my design configuration, and he used it, and it worked for his purpose. The trouble was everybody found out about it, and they wanted to use it. And so as a consequence of that, the 1D 3D cyclone was classified as best available control technology in agriculture. And so that's how that came about. And it actually came from an oil mill in California in terms of testing. We've had some success in that area. We also had some success in dust explosions and prevention of dust explosions. We had success doing that as well. Yeah, go ahead, Buster. I think if you go back and look at history and look at how the department faculty work together, such as the way Dr. Kunze worked with department. We need to reinvent that. We need to have more collegial exchanges and joint authorships of proposals and teaching. We need to do that. It's going to be tough. Now, let me add something here because I'm looking at the top of the room. There's Dr. Lacey up there. He's actually the director of CAKES, not Calvin Parnell as Dr. Searches. I apologize for that, Ron. I should have made that change early on. But we have some talent here on air quality. We want to take advantage of it. And let me add that young man up there from Econ. He was scared of heights when we went out there and did that sampling out there with Dr. Shaw. And Dr. Shaw asked me to go up there on top of that feed mill and take samples. And we need to do more of that. We have probably a wealth of young people that are going to make the future of this country, especially in agriculture. We want to give them every opportunity to be successful. That's my guide. That's sufficient? Anybody else have a comment, question? Talk to me. I think that's a good question, Charlie. I really think that it was a vision that Amber Wilkes had. And, you know, in engineering, you see something here and it's obvious that if you've got cotton fiddlers all sprung out across the countryside there, you need something that makes that difference in doing that. He knew that. He observed that. He made a decision. We need something like the module builder. And might add that he's working with Cotton Incorporated and Farmer Jones as well, and they recognize that as well. So I think we all every now and then.
They funded it on the fast.
They funded it. Well, they funded it on the fast track. That's correct. But I don't think it's just funding. I think it's an absolute observing it and doing engineering analysis and saying, how can I keep from having all these trailers around this gin? So I need to do something about that. And then he came forward, and I think they went through several iterations before it got to the actual module builder. And I think also he's working with Otto and he's working with Romy Sorensen and said, we need to know how moist that cotton has to be so we can store it for a length of time. And working with his colleagues doing that. I think it's something we have to find a way to reinvent. Reinvent's not the right word for it, but encourage younger faculty members to be looking for that secret. Yeah.
So when that
No. No, that's not it at all. At that time, in ASABE, I was the chair of the module building committee, and we basically defined the standards for modules. And pick cotton, because you can get more cotton in a module with pick cotton than you can strip cotton, we said we're going to make it 24 foot, 8 feet wide, 8 feet tall. That 8 feet wide, 8 feet tall was having to do with wide load. If it's 8 feet wide, it's a wide load. So then we came back and said, but for strip cotton, we need to have it 32 feet. Okay. Thinking that strip cotton, you have less dense, and therefore you have to have more room to do it. So we did that, and that committee was the Materials Handling Committee of P&E, Power Machinery. That Materials Handling Committee of Power Machinery is now the Cotton Committee of ASABE. I say, I think you have to have some standards. We had the people from Lummus and Continental Eagle and the other manufacturers of cotton equipment, cotton gin equipment there, and they participated in the process. Charlie's right. Charlie is absolutely right. What caused it? It may have been funding. I think more so it was Lambert. Let me tell you, I grew up picking cotton and a canvas bag up and down the road. And you got 5 cents for Pima cotton, and you got 3 cents for short staple cotton. I remember that. I'll never forget that. Okay, you're right. You're right. It was a hard job, and the trailers were not the answer, and trying to store cotton in dirt. Let me add this discussion. We're in for a tremendous change. When you have cotton gins that can gin a 500-pound bale in 32 seconds, that's 100 bales an hour. That's a lot of mass. Lubbock, we were at the big super gin out there in Lubbock, and they were ginning 20 bales an hour. I said, man, that's the most anybody's ever going to gin cotton, 20 bales an hour. No. We're at 100 bales an hour now. So things are changing. Okay, I've talked to enough folks, and I think I've heard anybody else. 5 minutes left. 15 minutes left. Okay, thank you. Okay. Yes. Well, you know, that's been a while, Kevin. Do you remember what expert witness story I told?
No, I just figured you had it.
Well, I got one someplace, but okay, I got one someplace. I'll tell. The first time I was an expert witness, and it had to do with a dust explosion. It was in Colorado, and I was on the plaintiff's side. And so I'm getting up there, and I'm getting ready to testify, and the person over there is on the defense. The lawyer for the other side was a person who looked just like Jimmy Stewart. I mean, absolutely. Same $1,000 suit. The guy was really, really well. And a good-looking guy, kind of like Russell. Good-looking guy, tall, thin. Good. He runs and gets in good shape and that kind of thing. And so anyway, the situation was I was talking about the loading on the end wall because I was saying that the failure on that end wall was a consequence of them loading it improperly. Okay? And they came back and they tried to get me to say something else. The humorous part about that is when I started out, it says, this is the load at the top. I'm going to say 2 pounds per foot. As you go down one more stage, it's 4 pounds per foot. And so the lawyer who had the Jimmy Stewart clothes on, he comes, and you go down 2 more, and it's 8 pounds per cubic foot, isn't it, per square foot? Isn't it, Dr. Parnell? And I'm sitting there saying, no, I don't think so. Let me think about this. And at the meantime, my lawyer is causing him to argue, and I'm leaning on the bench. I notice everybody in the audience is laughing. I look back, and this judge has given me the meanest look you ever seen in your life, because you're not supposed to lean on the judge's bench when you're giving testimony. But he didn't, but the other thing, when he said 8 pounds per square foot, he turned around and he was grinning. He had me suckered. If I said yes, that would won the case. You got to be careful. Thank you, folks. I appreciate your attention, and hope you have a good weekend.